Hello, this is Charlene. In this video, we're going to be doing exam 3 review problems. We're going to start with number 9 in this video. We have a youth soccer field and it is rectangular in shape. It has a perimeter of 96 meters. They also tell us that the length is 12 meters less than the width. And ultimately, they want us to find the width and the length of the soccer field. So the first thing we're going to do is draw a soccer field, which I've already done that down here. There's my rectangular shaped soccer field. It's a big rectangle. But let's talk about briefly again what the word perimeter means, just in case you need a reminder. So the perimeter can be broken down into its two parts. The peri part of perimeter means around. And the meter part of perimeter means to measure. So the thing is, though, altogether, perimeter means to measure around. So the perimeter of our soccer field is the measurement all the way around the soccer field. So if we measure all that, they say it's going to add up to 96 meters. Okay, they also tell us that that length is 12 meters less than the width. So the word is in math language means equals. So the length is equal to this. And so that means the length is based upon the width. So we're going to start with the width. We're going to say the W, the width, the length is 12 meters less. Well, what does 12 meters less? Does less mean add or subtract? It means to subtract. So 12 meters less means minus 12. So we now have an expression that tells us what the length is equal to. So let's go ahead and put this around our soccer field. We'll call this longer side the length. So it will be, in terms of the width, it's going to be width minus 12. And then this side over here will also be W minus 12. And then the short sides are just the width. So the goal is to get all of your expressions in terms of just one variable. If we have to deal with an L and a W around our soccer field, it would be very difficult to figure that out. But since we only have W's and W's and W's and W's, it's going to be relatively easy for us to work with. Okay, so again, the perimeter is the measurement around. So the perimeter, they told us, was equal to 96. So that means if I add this side and this side and this side and this side, they will all add up to 96 meters. So let's go ahead and do that. Let's say W minus 12 plus this W. And you can put it in any order because addition is commutative. So we can put it in any order. Doesn't matter which order they're in. Okay, so I got this one, this one, this one, and the last one I got one more W over here. One more W. And then all that is going to add up to the 96 meters. So now we just use our order of operations that we learned in Algebra 1. We're going to combine all of our like terms. So how many W's do I have? I have a W there, and there, and there, and there. So that means all total, I have 4 W's. And then I have a couple of constants, minus 12 and minus 12. We'll start negative, get more negative, you get even bigger negative. So it's minus 24. Minus 24 is equal to the 96. So we'll continue using order of operations, and we're going to, because we want to solve for that W, we want to figure out what the width is first, and then I will be able to figure out what the length is based on the width. So we're going to add 24 to both sides, plus 24, plus 24. These will cancel, and then I end up with 4W is equal to 120. And then the last step of solving this is to divide out the 4 using order of operations. So divide by 4, cancel, cancel. W is equal to 30. So we have now figured out what the width is. The width is equal to 30 meters. Okay, and now that we know the 30 meters, guess what we can do? We can take that 30 and plug it back into our expression for the length, because the length is equal to the width minus 12, the width less 12. So that means that the length is equal to 30 minus 12, and that is going to give us a length on our soccer field of 18 meters. So we are finished, and we can pat ourselves on the back for a good job, well done. Okay, our next problem says we're going to find the perimeter and the area of the figure given. Let's remind ourselves the perimeter is going to be the measurement around. So the measurement around all the outside lengths of our figure. Okay, so we need to make sure that all of our sides are labeled properly. So up here, I have 7.4 at the top, and I have a same size length opposite that, which is also 7.4. So I'm going to go ahead and label this 7.4. Okay, so the next thing I'm going to look at is the 3.1 centimeters. So here is 3.1 centimeters, and it's for that length right there. Well, there's a matching length right here. So that is also going to be 3.1. So let's go ahead and label that. Then we have a measurement of 3.1 here that's talking about this length, and its matching piece over here is also 3.1. So let's go ahead and label this 3.1. Okay, and that 3.1 doesn't look like a 3.1, does it? Okay, 3.1. Okay, then we also have a 3.1. This 3.1 is talking about this length, and its matching piece over here is 3.1, but it is not labeled. So let's go ahead and label this piece as well. Okay, and then we also have 3.1 right here, this length right here, and its matching length here is also 3.1. So let's go ahead and label that 3.1. Okay, trying to see if we have left anything out. Let's see. I have 1, 2, 3, 4, 5, 6, 7, and 8. I think we've measured everything that has 3.1. So I have 8 of those. Does that make sense? I have this length is 3.1, this length is 3.1, this length is 3.1, this length is 3.1, this is 3.1, this is 3.1, this is 3.1, and this is 3.1. So total, I have 8 of those. I have 8 lengths. So I'm going to say 8 times 3.1. And how many lengths of 7.4 did I have? I had 2. I had 7.4 here, 7.4 here. So I'm going to add 2 of those lengths. So 2 times 7.4. Okay, so what else do we need to label in our figure? Let's look at 5. Here is 5, and that's for this length right here, this 5 length. And this matching side over here is also 5. So we're going to label that 5. And then here I have 5 down here, and it's talking about this length. And there's a matching piece over here. This matching piece over here is also 5. So that means that I have 1, 2, 3, 4 lengths of 5. So I'm going to say plus 4 lengths of 5. Okay, so has every side been accounted for? I believe so, because we're only looking at the outer things. These dotted lines inside have nothing to do with the outer perimeter. Perimeter is always on the outside of a figure. Okay, so we should be able to add all this up and to find our total perimeter. So if we add all these things up, let's get our handy dandy calculator to let that do the work for us here. Okay, so here I have added 8 lengths of 3.1. I've added 4 lengths of 5 and 2 lengths of 7.4, and it gave me a grand total of 59.6. And of course, these are centimeters, so my final perimeter is going to be 59.6 centimeters. Okay, part B wants us to find the area of our figure. Area is going to be two-dimensional. The perimeter, if you remember, was in centimeters, just centimeters, because we were just measuring straight distances around the outside of our figure. Now, when we're measuring the area, we're talking about all this space inside here. So technically, you could divide up all this space and say, how many squares? How many squares are inside our space? And so that gives us a clue that our units are going to be centimeters squared because we're talking about two dimensions. We're talking about what is the length of that piece and what is the width of that piece. We're talking about two dimensions, lengths and widths, when we talk about the space inside of a figure. Okay, we are going to use these dotted lines to help us figure out how to calculate the area. I want to look at the biggest areas first. This rectangle right here is the biggest rectangle that's shown by the dotted lines, but I also have one that's identical to it down here. So I can, if I figure the area of one of those rectangles, I will know the area of both of them. Okay, but what are the dimensions of this rectangle? Well, this line right here is the same as the 7.4, so it's 7.4. And then what is the width of that rectangle? Well, it's going to be the 5. So this rectangle is going to be a 7.4 times 5 area. So when that one is 7.4 times 5, this one is also going to be 7.4 times 5. So if we use our handy-dandy calculator, we can see that that area is going to be equal to 37 centimeters squared. So just to keep ourselves straight, we're going to go ahead and mark that. So that's 37. And this one is also 37. It equals 37 centimeters squared. Okay, so the next space, okay, so I've got this space up here, this rectangle, and this is going to be what? It's going to be 7.4 times 3.1. So 7.4 times the 3.1. 7.4 times 3.1. So if we calculate that, that is going to give us an area of that space of 22.94. So this is going to be 22, uh-oh, okay, okay, 22.94. But this space right down here is identical to it, right here. So it is also going to be 22.94, 22.94. Okay, and what's the space that's left? This right here, this little rectangle, and it is identical to this one. And it is going to be 3.1 times 5. So what is 3.1 times 5? Well, let's let our handy dandy calculator do the work for us on that one too. So it's 15.5. So 15.5 and 15.5. So if you notice, I have two 37s, and then I also have two 22s 0.94s, 22.94 and 22.94. And then I also have two 15.5s and two 15.5s. So I can, if I want to, put those in my calculator like this. So if you notice, I have two 37s right there, and two 22.94s, and 2 15.5s, and it gives me a grand total of 150.88. So that means that my final answer, my final area for this entire figure is 150.88 centimeters squared. Okay, now there are different ways to go about this, and they're all acceptable as long as you don't leave anything out and you come up with 150.88. So this is not the only way to do this. I just chose to look for these two big
rectangles
first, and then I found these two matching rectangles, and then these final two rectangles, and then I added them all up for the grand total. But you can do it different ways, but this is one way of going about finding the area of this figure. Okay, number 11 says that we're going to find the area of the shaded region. It also tells us that our units are in centimeters, but of course it says centimeters, but because it is area, it is going to be two-dimensional. So our answer will actually be in centimeters squared when we get to the end. Centimeters squared, because area is two-dimensional. Okay, they also give us a hint here. They say that the area of a circle is equal to pi r squared. So this shape that we're looking at, it's like the outer shape is actually a rectangle. So it looks like we have a rectangle. The bigger figure is a rectangle. And then we're cutting out of that rectangle half a circle. So it is important that they gave us this little formula right here, this pi r squared for the area of a circle. But we also need to make sure that we remember that our area of a rectangle is length times width. But what we're going to do, we're going to take a rectangle, the area of the whole thing, and we're going to cut out half a circle. Well, what do you think cutting out implies? Is it cutting out something? Does it imply adding something or subtracting something? Yeah, it's going to be subtracting something. So we can think of this as taking the area of the whole rectangle and subtracting off the area for that half circle. And that will leave us with the leftover shaded area. So how are we going to set this up in terms of our equations? So the area rectangle, that's going to be length times width, right? And then that's going to be minus the area of half a circle. Okay, they said this is pi r squared, but we only want half of it. So we could do 1/2 of pi r squared. So length times width minus the area of half that circle, and that is going to leave us with the leftover shaded area. So what is the length and width of our rectangle? Well, they've given us this right here. They've given us that this length right here is 20. So that means that the diameter of our circle is also 20. This is also 20. So that's the diameter. So if that's the diameter, what is the length of the radius? The radius that goes from the center of a circle to the outside. Well, it's going to be half of the diameter. So that means that radius is going to be 10. Well, that length matches up with this side of my rectangle. So its length is also going to be 10. So that means the length times the width is going to be 10 times 20. And then I'm going to subtract off 1/2 pi r. We've now determined that our radius is 10. So pi r 10 squared. So when we calculate all that stuff, 10 times 20, that's going to be 200. And then 10 squared is going to be 100. Half of 100 is 50. So technically that would be like, we would end up with 50 pi. And then that would leave me my shaded area. But they want our answer in 2 decimal places, which means we're going to have to calculate out the pi and not leave it as a pi. So let's see what we can do here. We can do, aha! So we can do it with our calculator and end up having half of pi times 10 squared is equal to 157 with all of these decimal places, but they only want 2 decimal places. So if I look at the third one, well, let's wait to the end. Let's wait to the end. So that would be equal to 200 minus 157.0796. And what does that give me? Well, let's use our handy dandy calculator again. 200 minus that is going to leave me with a total leftover shaded area of 42.92 centimeters squared. So the final answer, 42.92 centimeters squared, and that is all of the shaded leftover space, all that area that's left over, 42.92 centimeters squared. Okay, number 12 says that you want to rent a storage space that measures 12 feet by 18 feet by 10 feet as the height. And they want us to find the total space that you will have. Well, total space is talking about volume. So let's think about what that looks like. Okay, so we've got this storage space, and maybe it has a door here on the side. Maybe it's got like a garage door size door so you could put stuff in. And we want to fill this storage space with stuff. So we're talking about all the space inside here. And that is the volume. But the volume is how many dimensions? Well, let's see. This would be 12 feet right there. That length would be 18 feet. And the height is 10. So we're definitely talking about 3 dimensions. So that means that our final answer is going to be in terms of feet cubed, because volume is 3-dimensional. We've got width and length and height. So the volume is equal to length times width times height. And that means it's going to be 12 by 18 by 10. And when we crunch all that out, that is going to give us 12 times 18 times 10 is going to give us a total volume. The volume of our storage space is going to be 2,160 cubic feet. Part B says, suppose that instead of renting a storage space, you decide to build a storage space with the same measurements using synthetic plastic. So they want to know, how much material will you need? Which means that we are going to find the surface area of the storage. And of course, the surface area is like this area of the top, this area of the side, area of the front, and you'll have the area of the back and the area of the bottom and the area of this other side. So you have to figure out the area of all those pieces and sides and the top and the bottom, and then add them all together. So they have given us a hint here. They said that the surface area is equal to 2 times W times H plus L times W plus L times H. But I'm going to kind of talk about it a little bit differently, because that feels to some people to be a little bit cryptic. It's not really, but I want you to think about it in terms of some practical terms. So again, I mentioned the fact that we have a front and a back. So the front would be this area right here. And if we find the area of that, it's going to be length times width, because that is a rectangle, length times width. So the length is going to be 12, but what is this height of it? Well, it's going to be the same as the 10. So it's going to be a 10 by 12. And we've got a back that is going to be identical to the front. We've got a front and a back. So if we calculate that, we're going to end up with 12 times 10, which is 120. So this is going to be 120 on the front side, and it'll also be 120 on the back side. So we multiply this times 2, and that gives us 240 square feet for the front and the back. Okay, so the next thing we need to think about is the top and the bottom. Well, the top right here is this piece right here, and it does have a length of 18 right here, and then it has a width same as this 12, so 12. So it's 18 by 12, and of course, there's also a bottom. There's a bottom that's going to be identical to the top. So here was the front, and now here's the top. This was the back right there, and this is of course the bottom down here. Okay, and when we crunch that out, that top of that's 18 by 12 is going to be 216, but then when we count the top and the bottom times 2, we get 432. So far we have for the front and back, we have 240, and for the top and bottom, we have 432 square feet. And what is going to be this side? This is like the right side, but then we're also going to have a left side over here. So this is going to be our right side. Let's see here, right, there we go, right side, but we're also going to have a left side over here that we can't see over here, but it's going to be identical. So its measurements are going to be the 18 by 10. So if we crunch that out, the 18 by 10, that's the left side and the right side, crunch it out, and then times 2 to count the left and the right. That means we're going to have a total of 360. So if we add up all of these numbers, the 240 plus the 432 plus the 360, that is going to give us our total surface area. So let's pull up our handy dandy calculator and add all those numbers up. We're going to add up, oops, let's get a clear screen here. La, 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 la. Clear. Okay, so we're going to do 240 plus 432 plus 360, and that gives us a total of 1,032. So that's going to be our total surface area. Our total surface area is going to be 1,032 square feet. So in order to build your storage unit from synthetic plastic, you would have to go buy 1,032 square feet of synthetic plastic to build the storage unit. Part C says if that synthetic plastic cost 29 cents per square foot, how much will it cost to build the storage unit? So we've got 1,032 square feet of synthetic plastic that we need to buy, and we are going to pay 29 cents per square foot. So square foot is the units that we're working with. We've already got that unit down here, so we could just multiply that times the 0.29 or the 29 cents times all that square footage, and it is going to give me the total cost to build my storage space. Total cost. Okay, so when we crunch that out with our handy dandy calculator, that is going to give me a total cost of $299.28. So that's not too bad. To build a storage space under $300, I don't think that sounds like a bad deal at all. Number 13 says the cylindrical container below has a diameter of 24 feet and a height of 18 feet. They also want us to find the surface area of the cylinder in square feet to 2 decimal places. They've also given us a hint. They said that the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. So let's go ahead and label our drawing. They tell us that the diameter is 24 feet. Well, on our drawing, they've actually labeled the radius. But how is the radius and the diameter related? Well, the diameter is 2 times the radius. So the diameter is actually going to be all the way across the bottom of the circular bottom of our cylinder. So that means the entire distance is going to be 24 feet. That is the diameter. So what is the radius? Well, the radius is half of that diameter. So that means that the radius here is going to be equal to 12 feet. So half across the circle from the center to the side of the circle is the radius, and that's going to be equal to 12 feet. Then they tell us that the height is equal to the 18 feet. So the height is equal to the 18 feet. Okay, so now let's go ahead and use our hint. So it says the surface area of our cylinder is going to be equal to 2 pi r squared plus 2 pi rh, which means that we are going to plug in a number for the radius here and the radius here and the height right here. So how would we write that all out? We'd write that as 2 times pi. The radius we decided is equal to 12, so it's going to be 12 squared plus 2 times pi times the radius of 12 times the height, which is 18. And so that is going to give us our total surface area for this cylinder. Now let's just talk briefly, what does the surface area mean? The surface area means that it's going to be the top and then all the sides all the way around, all the sides, and the bottom. So it's got a top, a bottom, and all the way around the outside. So that's what we're finding. The surface area is all of that, top and bottom, and around the sides. It's kind of like a soup can, right? It's the shape of a soup can. So if we put that in our handy dandy calculator, we can let it kind of do the work for us. So you see here, I've plugged in the 12 squared. There's the 12 squared for the radius, and here's the 12 for the radius, and 18 for the height. And when we calculate that out, the total surface area of our cylinder is going to be equal to 2,261.2 decimal places, means the 6 is big enough to change the 4 to a 95. So 95, it is area. So area is always squared two-dimensional. So these are feet, so it's going to be feet squared. Okay, surface area of our cylinder, 2,261.95 square feet. Okay, part B of number 13 says how many gallons of water can the cylinder hold? That is, find the volume. But the bottom line question they're wanting us to find out is how many gallons. Our final answer will be in gallons. But our hint says that the volume of the cylinder is equal to pi r squared times h. And they also give us the hint that 1 cubic foot is approximately 7.48 gallons. So let's talk about this volume equation. So the volume of a cylinder is equal to pi r squared h. So what does that mean if we break it down? Well, I want us to think back and remind ourselves that the area of a circle is equal to pi r squared. That is the area of a circle formula. Well, guess what's inside of this volume equation? Pi r squared. So this is like saying that the area of a circle multiplied times the height will equal the volume. So it's kind of like we are getting the area of a circle. There's the area of a circle, okay? And then we're multiplying it times the height. So I'm going to get the area of a circle, and then I'm going to keep adding it and adding it and adding it and adding it and adding it all the way up as tall as the height. So it's the area of a circle, that bottom circle, and we just keep adding, 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 adding. And when we keep adding, we're actually multiplying. So this is like the area of a circle multiplied all the way up equal to the height. So hopefully that kind of gives you some kind of visual perspective of what this volume of a cylinder equation is all about. But we're going to go ahead and fill in the parts to it. Our volume of our cylinder is going to be equal to the pi times the radius, which we determined in part A was 12. So it's going to be 12 times 12 squared. And then times the height, which is 18. So times the height, which is 18. And like I said, area of the circle, add it up over and over and over again, which means multiply times the height. Okay, so if we put that in our handy dandy calculator, we will get that the volume is equal to 8,143 cubic feet. Cubic feet, because like you said, this area is two-dimensional, but then we have another height, which is another dimension. That's one dimension. So I've got two dimensions with the area, one dimension with the height. So the final answer is cubic feet. But that is not our final answer. Our final answer needs to be the gallons. So we're going to use this ratio that they actually gave us. Okay, so we've got a number of 8,143 cubic feet. I do not want my answer, my final answer, to be in cubic feet. I want my final answer to be in gallons. So what I'm going to do is I'm going to put this number that I have, that I've calculated to find the volume, I'm going to put it over the invisible 1 to remind myself that it is in the numerator. And then I'm going to multiply it times a conversion factor that is going to help me get rid of the cubic feet that I do not want in my final answer so that I can have gallons in my final answer. So the thing is, though, is that this ratio, this is 1 cubic feet is approximately 7.48, can be turned into a ratio. That's what we're going to put down here. So we're going to put the 1 cubic feet in the denominator. So 1 cubic feet, or foot, I guess we could call it, 1 cubic foot is going to go in the denominator, and 7.48 gallons, which is what it is, approximately 7.48 gallons. But this allows me to cancel out the cubic feet in the numerator, cancel out the cubic feet in the denominator, and that leaves me with the gallons that I actually want. So when I multiply 8,143 times 7.48, that is going to leave me with the number of gallons that is contained in my cylinder. So here we go. My final answer is going to be 60,910. We'll round it up. 64, I'm going to round that up to 910. So 60,910 gallons is how many gallons this cylinder will hold. Okay. Part C is the final question for this video, and it says, if the water cost $3.28 per 1,000 gallons, how much to the nearest dollar will it cost to fill the cylinder? Okay, so we determined that our cylinder could hold 60,910 gallons. The cost per 1,000 is $3.28. So this part right here is another ratio that they have given us. $3.28 per 1,000 gallons. Well, again, I've got units of gallons here, but I want a cost as my final answer. So I do not want gallons in my final answer. So I'm going to put that over the invisible 1 to remind myself it's in the numerator, and I'm going to get rid of the gallons. That means I'm going to put 1,000 gallons in the denominator, 1,000 gallons in the denominator of 1,000 gallons is going to cost us $3.28. This allows us to cancel out the gallons, and it leaves us with the dollars, the units that we want our final answer to be. So when we put that in our handy dandy calculator, we get a cost to fill our cylinder with 60,910 gallons of water. The cost is going to be $199.78 because the 4 is not big enough to change the 78. So $199.78. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.